So I did some examples of arc lengths of space curves. And the first one I have here is R of t is root 2 times t, comma e to the t, comma e to the negative t for 0 less than or equal to t, less than or equal to 1. So let's take a look at a picture of what that space curve looks like. So here we go. It's got this kind of a look to it. So maybe you can get yourself an idea approximately how long that curve is going to be. So here it is, looking at it from above, from the two-dimensional perspective, and here it is looking at it from the side, from the three-dimensional perspective. So what's our rule? What's our rule for the arc length? The arc length is the integral of the speed. Notice speed times change in time. Summing up speed times change in time is distance. So that kind of fits models that we've thought about in terms of algebra. So what is the speed? So let's start with the velocity here. R prime of t is root 2 and e to the t and negative e to the negative t. So that's our velocity. So the speed is the square root of r prime dot r prime, also known as the magnitude of the velocity. So what will that be? Root 2 times root 2 is 2 plus e to the t times e to the t is e to the 2t plus negative e to the negative t times negative e to the negative t is plus e to the negative 2t. Well, that doesn't look great. We need to do some work with this to get it in a format that we can actually use to simplify it. So what I'm going to do here, magnitude of r prime of t, we're going to rewrite that e to the negative 2t as 1 over e to the 2t. Which will be, if we get a common denominator, 2e to the 2t plus e to the 4t plus 1 all over e to the 2t once we get our common denominator. Which you'll notice this problem has been well designed so that this simplifies nicely. So continuing with our algebra, then what do we have here? E to the 4t plus 2e to the 2t plus 1 is simply e to the 2t plus 1 squared divided by the square root of e to the 2t. So normally speaking, the square root of something squared is its absolute value, but here e to the 2t plus 1 is always positive, so that will just simply be e to the 2t plus 1. And this, of course, the square root of e to the 2t is just e to the t. So now what do I get? I get e to the 2t over t plus 1 over e to the 2t. And all of this is giving us the speed. Again, remember, our arc length is the integral of the speed over all t. So how does this simplify? What is the speed? E to the 2t over e to the t is e to the t, plus 1 over e to the t is e to the negative t. So that's our speed. To get our arc length, we've got to integrate that from 0 to 1. So let's quickly do that. So here's where we are. The antiderivative of e to the t is e to the t. The antiderivative of e to the negative t is e to the negative t over negative 1. And we're going to evaluate at as t ranges from 0 to 1. So we get s arc length is e to the t minus e to the negative t as t ranges from 0 to 1. Plugging in those 1 values, what do we get? We get e to the 1 minus e to the negative 1. Plugging in 1 minus plugging in 0. E to the 0, 1 minus e to the negative 0. 1 minus 1 is just going to give me 0 there. So we get S is E minus 1 over E, which is what? E times E is E squared minus 1 over E. And what is that approximately? Let's give ourselves a ballpark figure on that. And it's about 2.35. So let's go back and take a look at our picture to see if that seems reasonable. Can we believe that this curve is a little bit more than 2? If we see it directly above in 2 dimensions, we see 2 is from here to here. So seeing that a little bit more than 2, that seems reasonable, at least in that shadow of it. And then looking at it in 3D as well, it seems to me that a little bit more than 2 certainly seems reasonable. Let's go ahead and do one more problem. So here we go. We want to find the arc length of r of t is 12t plus 8t to the 3/2 plus 3t squared. As t ranges from 0 to 1, what do we need? We need our prime of t. What is my derivative? 12. 8 times 3/2 t to the 1/2. 6t. So what does that give me? R prime of t is 12. 8 times 3/2, that's 12 t to the 1/2, or 12 root t. And 6t. So we have our velocity. Of course, we need our speed. Arc length is the integral of speed. So what is the speed? Speed is the square root of 12 squared plus 12 root t squared plus 6 times t squared. And what is that going to give me? That gives me some big numbers. What does that give me? Simplifying the algebra we get here, but there's a 36 common to all of those pieces. So let's factor out a square root of 36. And this is the result. But isn't this nice? Root 36 is 6. And this is, of course, t squared plus 4t plus 4 is t plus 2 squared. So what does our speed become? It's 6 times the absolute value of t plus 2, but you can see t is ranging from 0 to 1. So that will just be 6 times t plus 2. And to get arc length, I'm going to need to integrate speed from 0 to 1. So we know that arc length integral from 0 to 1 of the speed. So that will be the integral from 0 to 1 of 6 times t plus 2 dt, which of course becomes integral from 0 to 1 of 6t plus 12 dt. So my antiderivative is 3t squared plus 12t, evaluated as t goes from 0 to 1. Plugging in our endpoints, 3 times 1 squared plus 12 times 1 minus 3 times 0 squared plus 12 times 0, and we get s is 15. So let's take a look at our picture and see if that seems reasonable. So here is the top view. Now, could you believe that this is about 15? Again, we're not seeing how much it's moving in that third dimension, but from here to here is 16, and we know we have a little bit more play in the third dimension. That seems reasonable. So let's go ahead and switch it to 2D. And could we believe, excuse me, to 3D, could we believe that this is 15? A little harder to see here, but I think it's reasonable for us to consider that 15 is at least in our range.